Hello everyone, welcome to Bethal Education. This is NRP. Today I'm going to introduce you about an interesting topic in trust members. It is about identifying zero force members in trust. There are 5 basic rules or principles to be followed to identify the zero force trust members without actually doing any sort of calculation. At the end of this video, you will learn how to simplify a complex looking trust as shown on this screen before you start solving your trust. Just to be clear, I'm not going to cover the actual process of solving a trust using a sectional or node method, but rather teach you a process that removes unnecessary trust members, that is the zero force carrying members. Without further ado, let's work on these principles. Rule number 1. Two non-collinear members at a joint with no external load carry zero force. This means if there are only two non-collinear members at a joint, and it doesn't have any external load at that joint, then both of these members are zero force members. Now let's apply rule number 1 on this example. So we'll be looking at the non-collinear members at a joint. Just to make sure, remember the joints must have only two members for rule 1 to apply. Non-collinearity exists when the axis of each members make an angle with each other. Collinear members always make 180 with each other. In this example, the node E has two members, DE and EF. And if you look at this node E, we can see the members DE and EF are non-collinear, and the node doesn't have any external load. Yes. And there are only two members at this node E. Okay. So it meets all the requirements of rule 1. Thus, members DE and EF carry zero force. Now let's try to look at similar locations at other nodes, and looks like we don't have any other nodes that can satisfy rule number 1. So that's all for now. Let's move on to rule number 2. Okay, the rule number 2 says that if two members at a joint containing only 3 members are collinear with no external load at that joint, the third member, which is the non-collinear member, carries zero force. So let's look at this example up here. We can clearly see joint C. Here it has members BC, CD, and CG. BC and CD are collinear, and CG is the non-collinear member. And we can see that there is no external load at this joint or node. So the member CG must be carrying zero force. So this is as per rule 2. And we'll try to find similar joints or node at other occasions on this truss, but I think for now that is all for rule number 2. So yeah, let's move on to rule number 3. Okay, now it's rule number 3. Rule number 3 is not entirely a new rule, but combination of rule 1 and 2. It says that if we assume that the zero force members identified from rule 1 and 2 do not exist, we can reuse rule 1 and 2 on the new structure. Let's see what that means. So you can see the new structure formed after removing the zero force members from rule 1 and 2. We will now look for nodes or joints which satisfies rule 1 and 2. Unfortunately for this example, we have no other nodes that satisfies 1 and 2. But we'll see its application on the second example. So let's move on to rule number 4. Okay, the rule number 4, it's just the property of support geometry. The fact that the roller support doesn't have any horizontal reaction, the horizontal member connecting that roller support carries zero force. as you can see on this example. So this example of here is it's not entirely a new example, but the outcome from rule 3, as you know, this one looks much simplified than we had at the beginning of this video. So about rule 4, the horizontal member AG doesn't have doesn't carry any force because there is no horizontal reaction at roller support. Also, at pin support at node F, since we don't have any horizontal force acting on the truss, there won't be any reaction at this joint or pin support. So the member GF must carry zero force in absence of a horizontal force acting on the truss structure. Just remember, if there was a horizontal force at some point on the structure, then there would be a reaction at the pin support and the force on GF at that condition, at that situation, won't be zero. But for now, we don't have any horizontal force acting on the truss structure, so the force on member GF is zero. That is all. So let's move on to rule number 5. Okay, the final rule, rule number 5. Rule number 5 is based on the principle of equilibrium, which is the summation of all horizontal forces is zero and the summation of all vertical forces is zero. For this particular video, we won't need the third moment equilibrium equation. For this example, we can apply this, but we'll see it on example 2. To apply this, we should remember that for a diagonal member to carry load, there should be an additional member in both horizontal and vertical direction at the same node. We will see a detailed explanation on example 2, but for now, this is all for rule number 5. This is the final version of the structure. So this looks way simpler and less scary than what it was at the beginning of the video. Once you practice all 5 rules, you should be able to apply them within minutes. As you can see, you don't have to worry about other members because they are all zero. This is when you should start solving your truss. It should make your calculations easier and take less time than before. Now let's move on to example number 2. Before we move on to example number 2, please revise these rules or principles. Rules 1 to 4 will be used most frequently. Make sure you understand all of these. If you have any confusion, comment below on the comment section and let me know. Okay, in this example, we have a load at joint C only. So let's start with rule number 1. At node A, the members AB and AC carry zero force as per rule 1. At node G, members FG and GI carry zero force as per rule 1. I think that's pretty much for rule 1. So let's move on to rule 2. At node D, since BD and DF are collinear, so this must carry zero force. Rule 2. At node K, this carries zero force because of rule 2. I think that's pretty much for now. So let's move on to rule 3. Okay, for rule number 3, we will remove all the zero force members that we got from rule 1 and 2 and then reapply rule 1 and 2 on the new structure. So on my right, we have the new structure, which is formed by just assuming that we don't have those zero force members. Okay, now reapply rule 1 and 2 on this structure. Let's go with rule number 1. I don't see any rule number 1 application here. So let's move on to rule number 2. I don't see any rule number 2 application either. Let's go to rule number 4 and see if rule number 3 applies then. Okay, according to rule number 4, we are gonna look at the supports. Up here at node L, roller support has a horizontal member LM. Since there is no reaction at the roller support, this member should carry 0 force. Now let's quickly look at rule number 5, and then we will come back to rule number 3. As per rule number 5, the member JM should carry 0 force because it's a diagonal member, but there is no horizontal member that can carry its horizontal component. If you are solving this truss, you will do something like Jm cos theta is equals to Lm. Since Lm is 0 force member, Jm should also be 0. This is the equilibrium principle. At node C, you can see we don't have any horizontal force, so there is no horizontal force on member CE. So this is rule 5. Rule 5. Okay. Now we will go back to rule number 3. So for rule number 3, we will remove all these 0 force members and reapply all other principles, basically 1 and 2. You can see at node J, Sj and Jl are collinear, and this non-collinear member should be 0 as per rule 3, or basically rule number 2. And let's look at some other locations that does the same. I don't see any other locations or other members that carry 0 force. This is the final simplified version, and it looks way simpler than what it was at the beginning. I'm pretty sure it should take less time, should make your calculations much easier, and avoid any errors while doing those long calculations. Once you understand all 5 rules, you should be able to apply these within few minutes, and you don't have to worry about all other members because they are all 0. This is when you should start solving your truss, because you have fewer members to solve when you know which members carry 0 force. Okay, this is all for today. I think this is one of the very unknown trick for structural engineers. Once you master this, you should be easily able to visualize 0 force members in old truss bridges, and you can sound smarter in front of your colleagues. Thanks for watching. Hope you like this video. For more content, please subscribe this channel. Also, don't forget to like, subscribe, and comment down below.